We gaze at the stars, mesmerized by their beauty. But hidden in the cosmos's shadows are nightmares science dares to imagine. Each galaxy teeming with stars, planets, and maybe even life. It's beautiful, mysterious, and a source of endless wonder. But have you ever stopped to think what happens at the end? We humans are obsessed with beginnings and endings. It's in our stories, our myths, our very understanding of the world. We mark time, celebrate births, mourn deaths. It's natural then to ask about the fate of the universe itself. What if everything, you, me, time itself, vanishes? Scientists have dedicated themselves to unraveling the mysteries of the cosmos. Are you ready to explore the dark side of cosmology? To understand how the universe might end, we need to rewind. Go back to the very beginning, to the event that started it all, the Big Bang. About 13.8 billion years ago, our universe exploded into existence, expanding from an incredibly hot, dense state. It's been growing and evolving ever since. Think of a balloon being inflated. Galaxies are like dots on the balloon's surface, moving apart as it inflates. For a long time, scientists believed this expansion would eventually slow down, maybe even reverse. But then, observations started throwing a wrench in that theory. Scientists discovered that the universe's expansion wasn't slowing down as expected. It was accelerating. Dark energy was counteracting gravity, pushing everything apart at an ever-increasing rate. The accelerating expansion led scientists to develop new theories, each more mind-boggling than the last. These theories, often described with names like the Big Freeze, the Big Rip, and even vacuum decay, explore the extreme consequences of a universe dominated by dark energy. We're about to delve into the heart of these cosmic horrors. We'll explore scenarios where stars die out, galaxies become isolated islands in an ever-expanding void, and the very fabric of space-time is ripped apart. But before we venture into the darkness, remember this. These terrifying theories are a testament to the power of human curiosity. So, brace yourselves as we explore the terrifying ways the universe could end. Imagine a universe where the lights are slowly going out. That's the essence of the Big Freeze, also known as the heat death of the universe. It's a scenario where the universe continues to expand at an accelerating rate, driven by the relentless push of dark energy. As the universe expands, galaxies are pulled further and further apart. Over unimaginable spans of time, the vast distances between galaxies become insurmountable. No new stars will collide and ignite, no new galaxies will form, the last light goes out, heat death has come, stars, those magnificent balls of burning plasma, have finite lifespans. They eventually exhaust their nuclear fuel just like a car running out of gas. As stars die, they go out in different ways depending on their size. Some fade into white dwarfs, others explode as supernovae, briefly illuminating the cosmos with their final breaths. But ultimately, the cycle of star birth and death comes to a halt. In the Big Freeze scenario, galaxies gradually transform into stellar graveyards. The once bright spiral arms, filled with young hot stars, become faint and diffuse. Star formation grinds to a halt, and the remaining stars age and die off, leaving behind remnants like white dwarfs, neutron stars, and black holes. The Milky Way, our home galaxy, will merge with its neighbor Andromeda in about 4 billion years. But this collision, a spectacular event in itself, won't be enough to reverse the overall trend. The merged galaxy will eventually suffer the same fate, a slow decline into darkness and isolation. Imagine looking up at the night sky billions of years from now. Instead of a dazzling tapestry of stars, you'd see mostly darkness, punctuated by the faint glow of aging stars and the occasional distant supernova. The universe would be a much emptier, lonelier place. Heat, always flowing from hotter to colder regions, will eventually be evenly distributed throughout the universe. As the universe continues to cool and expand, black holes will become increasingly dominant. These cosmic monsters, formed from the collapsed cores of massive stars, possess gravitational pull so strong that not even light can escape their grasp. In the far future, black holes will feast on the remnants of dead stars and even merge with each other, growing ever larger and more powerful. The dance of these behemoths will release gravitational waves, ripples in the fabric of spacetime, which will propagate through the dying universe. While the Big Freeze might seem like a bleak and lifeless scenario, some scientists have speculated that life could find a way to persist even in this extreme environment. Perhaps advanced civilizations could harness the energy of black holes or find ways to survive in the faint glow of white dwarfs. However, such civilizations would face incredible challenges. In the very distant future, after countless trillions of years, the Big Freeze will reach its ultimate conclusion. The universe will become a vast, cold, and empty expanse. Even black holes, those seemingly eternal objects, will eventually evaporate through a process known as Hawking radiation. This incredibly slow process will eventually cause even the largest black holes to disappear, leaving behind nothing but a faint whisper of radiation. The universe will reach a state of maximum entropy, where everything is evenly distributed and there are no more energy gradients to exploit. No stars, no galaxies, no planets, no life, just a cold, dark, and empty void. It's a sobering thought, but also a reminder of the vastness of time and the impermanence of all things. For decades, the Big Crunch reigned supreme as the most popular theory for the universe's end. It was a simple, elegant, almost poetic idea: what goes up must come down. In this scenario, the expansion of the universe isn't a one-way trip, it's a journey with a dramatic U-turn. Imagine the universe as a ball thrown skyward. Initially it ascends with great speed, but gravity gradually slows its ascent. Eventually the ball reaches its highest point, momentarily hangs in the balance, and then begins its inevitable descent back to Earth. The Big Crunch envisions a similar fate for the cosmos. The outward push of the Big Bang eventually loses its momentum against the relentless inward pull of gravity. The expansion slows, stalls, and then reverses. As the universe contracts in the Big Crunch scenario, the carefully ordered dance of galaxies transforms into a chaotic mosh pit. The immense distances between galaxies, once expanding, now shrink at an alarming rate. Collisions become inevitable. Galaxies, each a swirling metropolis of billions of stars, smash into each other with unimaginable force. These aren't just fender benders, they're cosmic pile-ups, throwing stars out of their galaxies and setting off dazzling, deadly displays of star formation and destruction. Our own Milky Way galaxy, currently on a collision course with the Andromeda Galaxy, wouldn't be spared. In the Big Crunch, this collision becomes just one event in a chain reaction of galactic mergers, a cosmic feeding frenzy as larger galaxies consume smaller ones. Imagine the night sky in this contracting universe. The closer the universe gets to the Big Crunch, the more extreme the conditions become. Temperatures soar as the cosmic background radiation, the faint afterglow of the Big Bang, gets amplified by the shrinking universe. Space itself becomes denser and hotter, like air being compressed in a bicycle pump. This intense heat would be deadly. Stars wouldn't just collide, they'd be cooked from the inside out as the universe around them turned into a cosmic oven. Planets would be vaporized, their constituent atoms ripped apart in the unimaginable heat. Eventually, even atoms themselves would be unable to withstand the crushing pressure. They'd break down into their constituent protons, neutrons, and electrons, creating a sea of superheated plasma not seen since the universe's earliest moments. What happens after the Big Crunch? That's where things get really interesting, and even more uncertain. Some physicists have proposed that the Big Crunch isn't the end, but rather the beginning of a new cycle in an eternally repeating universe. This idea, known as the Big Bounce, suggests that the singularity at the end of the Big Crunch could spark another Big Bang, leading to a new phase of expansion, cooling, and evolution. The universe, in this model, would be like a phoenix, constantly rising from the ashes of its own destruction. However, the Big Bounce remains highly speculative. We simply don't know enough about the physics of singularities to say for sure what might happen. It's possible that the Big Crunch truly is the end, a point of no return, a cosmic curtain call after which there's nothing, no space, no time, no existence as we know it. The Big Rip. Just the name sends shivers down your spine. It's a theory that takes the accelerating expansion of the universe and cranks it up to 11, leading to a cosmic finale that's as abrupt as it is devastating. Remember dark energy, that mysterious force we talked about earlier, the one pushing everything apart at an ever-increasing rate? Well, in the Big Rip scenario, dark energy doesn't just win, it goes into overdrive. Imagine a runaway train, its speed increasing exponentially with no way to apply the brakes. That's the Big Rip universe, a cosmic joyride headed for a catastrophic crash. The expansion becomes so extreme that it eventually overwhelms all other forces in the universe, including gravity itself. This isn't just about galaxies drifting apart anymore. In the Big Rip, the cosmic unraveling begins with the largest structures in the universe, galaxy clusters. These massive collections of galaxies, held together by gravity's invisible hand, start to feel the strain as dark energy's influence grows. Imagine a tug of war, with gravity pulling inwards and dark energy pulling outwards. In the Big Rip, dark energy wins this cosmic contest, pulling galaxy clusters apart and scattering their constituent galaxies into the void. But the destruction doesn't stop there. As dark energy's pull intensifies, individual galaxies themselves begin to feel the strain. The elegant spiral arms of galaxies like our own Milky Way would warp and distort, their once orderly rotations thrown into chaos. As the Big Rip progresses, the disintegration of the universe becomes more intimate, more terrifying. The very fabric of space-time, the stage on which the cosmic drama unfolds, begins to fray at the seams. Imagine a piece of cloth being pulled taut, its threads straining under the pressure. That's space-time in the Big Rip, stretched and distorted by the relentless force of dark energy. Stars, once mighty balls of burning plasma, would begin to feel the strain. Their outer layers would be peeled away, their cores exposed like raw wounds in the fabric of space. Planets, no longer able to maintain their orbits, would be ripped from their stars, sent hurtling into the abyss. The final moments of a Big Rip universe are hard to fathom. As dark energy's pull reaches its peak, the very atoms that make up everything we know would be ripped apart. Imagine the fundamental building blocks of matter, the protons, neutrons, and electrons being torn asunder. In these final instants, the universe would transform into a chaotic soup of subatomic particles, a cosmic demolition derby where the rules of physics as we know them would cease to apply. Time itself, once a steady and reliable metronome, would likely become meaningless, warped and distorted beyond recognition. Some physicists speculate that as the Big Rip reaches its climax, the universe wouldn't just be torn apart, it would be instantly shredded, erased from existence as if it had never been. It would be the ultimate cosmic reset, leaving behind a void, an emptiness so profound that it defies description. What lies beyond the Big Rip? It's a question that sends even the most seasoned physicists into the realm of speculation. Some theories suggest that the Big Rip wouldn't be the end of everything, but rather a transition to a new state of existence, perhaps a universe governed by entirely different laws of physics. Others propose that the Big Rip would lead to a kind of cosmic amnesia, wiping the slate clean and allowing for the emergence of a new universe, perhaps one more hospitable to life as we know it, but these ideas remain firmly in the realm of conjecture. The Big Rip, if it comes to pass, represents the ultimate limit of our current understanding of the universe. It's a stark reminder of the immense power of the cosmos and the fragility of our own existence. It's a theory that challenges us to confront the biggest questions of all. Where did we come from? Where are we going? And what, if anything, lies beyond the end of everything we know? The Big Freeze and the Big Rip are terrifying in their scope, but vacuum decay is different. It introduces instantaneity. The universe might be inherently unstable, like a house of cards. To understand vacuum decay, we delve into quantum mechanics. At the heart lies the vacuum state, the lowest energy state. Virtual particles pop in and out of existence. What if the universe is stuck in a false vacuum? Now imagine that somewhere in the vast expanse of the universe, a tiny quantum fluctuation occurs. It's a random, unpredictable event, the kind that happens all the time at the subatomic level. But this time, it's different. This particular fluctuation creates a tiny bubble of true vacuum, a region where the universe exists in its absolute lowest energy state. It's like a seed of ultimate stability planted in the unstable soil of the... Here's the terrifying part. Once this bubble forms, it doesn't just sit there, it expands, rapidly. Think of a soap bubble being blown, its surface growing outwards at an incredible speed. But the true vacuum bubble is empty space. It's converting everything in its path, transforming the false vacuum into true vacuum, annihilating the very fabric of the universe as we know it. This expansion wouldn't be a gentle process, it would be a wall of annihilation, a wave of destruction traveling at the speed of light, leaving nothing but the true vacuum in its wake. Stars, planets, galaxies, everything would be instantly erased, their existence wiped clean as if they'd never been. And the scariest part? We wouldn't see it coming. Light itself wouldn't be able to outrun this wave of destruction. There would be no warning, no time to prepare, no chance to say goodbye. One moment we'd be here living our lives, contemplating the cosmos, and the next we'd be gone. Some physicists have likened vacuum decay to a cosmic razor blade, slicing through the universe with surgical precision, leaving nothing but emptiness in its wake. It's a chilling thought, the idea that our universe, our home, could be undone by a random quantum event, an event so small, so insignificant, that it would be like a grain of sand toppling a mountain. Is there any escape from vacuum decay? The short answer is, probably not. If a true vacuum bubble formed somewhere in the universe, we'd be powerless to stop it. Our current understanding of physics offers no solutions, no technological marvels that could shield us from such an event. Some theoretical physicists have toyed with the idea of creating our own true vacuum bubbles, perhaps harnessing their energy or using them as a form of cosmic propulsion. But these ideas are highly speculative, bordering on science fiction. Others have suggested that if we could somehow detect a true vacuum bubble approaching, we might be able to escape its grasp, perhaps by creating wormholes or finding some other way to travel faster than light. But again, these are ideas that lie far beyond our current technological capabilities. For now, vacuum decay remains one of the most terrifying and unsettling theories in all of science. It's a stark reminder of the vastness of the unknown, the fragility of our existence, and the humbling realization that there are forces in the universe far beyond our control, forces that could erase us in an instant, leaving no trace that we ever existed. We've journeyed to the very edge of existence, peering into the abyss of the universe's potential demise. We've explored chilling scenarios, each more unsettling than the last, each a stark reminder of the universe's power and our own fleeting existence within its grand cosmic narrative. It's easy to feel small, insignificant even, when confronted with the universe's ultimate mortality. What meaning can our lives have when faced with such cosmic indifference, such utter annihilation? But amidst the terror, amidst the humbling vastness of it all, there's a strange comfort to be found. The universe, for all its terrifying possibilities, is also a source of profound beauty, intricate order, and endless wonder. The very laws of physics that govern these doomsday scenarios are the same laws that allowed stars to ignite, galaxies to form, and life itself to emerge on at least one tiny planet orbiting an unremarkable star. And while the universe may have an expiration date, a cosmic curtain call billions or even trillions of years in the future, that end is still unimaginably far away. We have, in the grand scheme of things, an incredible amount of time to unravel the universe's mysteries, to appreciate its beauty, and to leave our own mark on the cosmos. The terrifying ways the universe could end remind us of our place in the cosmos. We are just a tiny speck of life on a tiny planet orbiting a tiny star, but that doesn't make our existence any less precious. Our awareness of the universe's vastness makes our time here remarkable. We are the universe becoming aware of itself. So, when you look up at the night sky, remember you are part of something ancient and awe-inspiring.